All right, let's talk about something we've all worried about. You build this amazing application, it has this slick search bar, and you just live in fear that a user is going to see an error instead of results. Well, today we're going to build a fortress for your search experience using Azure AI Search to make it not just smart, but practically unbreakable. I mean, let's just put ourselves in the user's shoes for a second. They type something in, hit enter, and boom, an error. It feels awful, right? And it's so much more than just a little glitch. It's a breach of trust. For a business, it could mean lost sales. And for any app, it just completely undermines confidence in your entire platform. That's exactly why we're digging into this today. So here's the game plan. We're going to build up our reliability strategy like we're putting on layers of armor. First, we'll get on the same page about why this is a team effort. Then, we'll map out the basic blueprint. From there, we'll add our first layer of armor for those small, annoying glitches, then the heavy armor for major disasters, and we'll wrap it all up with a super practical checklist you can use right away. So where do we even begin this quest for an unbreakable search? Well, it starts with a really simple but absolutely crucial idea. Reliability isn't a feature you just flip on. It's a partnership. It's a shared responsibility between you and your cloud provider. And look, this isn't just my opinion. Microsoft puts this front and center in their own documentation. They're basically saying, hey, we've built you this incredible toolkit with all these features for resilience and recovery, but you are the architect. It's up to you to understand the tools and then actually use them to build something strong.
Okay, so if we're the architects of this fortress, we need to know our building materials, right? What are the stones and mortar we're working with? Before we can protect our search service, we have to understand its core components.
First up, we have the replica. And honestly, the best way to think about a replica is like a backup singer. One singer can handle a small coffee shop gig, but if you're playing a stadium, you need more voices to handle the load. Plus, if the lead singer gets a sore throat, the backup singers can carry the tune. It's the same here. More replicas let you handle more queries, and they keep your service online if one of them needs to be taken down for maintenance. Next up, availability zones. Imagine these as totally separate concert halls in the same city. Each one is its own independent building with its own power, its own cooling, the whole shebang. So if one hall has a sudden power outage, the show can instantly move to one of the other halls, and the audience, they probably won't even notice. This is Azure's built-in protection against something going physically wrong in one specific spot. Okay, now this is where the rubber really meets the road. Adding replicas is how you directly build up your resilience. If you're running with just one replica, you're kind of flying without a net. You get no service level agreement. That's the SLA, Microsoft's official promise for uptime. The second you add a second replica, bam, you're now fault tolerant for queries and you actually qualify for that SLA. Then you jump to 3 and you've hit the gold standard, protecting both search queries and when you're adding new data to your index. All right, we've got our blueprint, we know the pieces, now it's time to put on that first layer of armor. We're going to start by tackling the most common enemy you'll face in the cloud, the transient fault. So what are transient faults? You can just think of them as temporary hiccups. They're these little self-correcting errors that are just a normal part of life in any massive distributed system like the cloud. A network connection might blip for a second, and then it's fine. The key thing to remember is that you should expect these to happen. The solution isn't trying to prevent them, it's to handle them gracefully in your code by simply trying the request again. So who does what when these little glitches occur? Well, on your side, your application's code absolutely needs to have a smart retry strategy. Something like exponential backoff, which is just a fancy way of saying you wait a little bit longer between each retry so you don't overwhelm the service. Now, the good news is, for some things, Azure has your back. Their AI indexers already do this for you automatically. And on the service side, as we've said, having at least 2 replicas means you stay online even during routine maintenance. Okay, we've handled the small stuff, we've got our basic armor on, now it's time to bring out the heavy armor. Let's talk about surviving the big ones. What happens when an entire data center or even a whole geographic region goes dark? Now, it is so important to understand the difference between these two disaster scenarios. A zone failure, that's one data center in a region having a bad day, is something Azure is designed to handle for you automatically, if you've configured your service correctly. But a region-wide failure? Whoa, that's a whole different beast. It's incredibly rare, but if it happens, your survival depends entirely on the disaster recovery plan that you designed and built, which usually means having a backup service ready to go in a completely different part of the world. So, how do you get that awesome automatic protection against a zone failure? You'll be happy to hear it's surprisingly easy. There are just 3 boxes to check. First, your service has to be in a region that actually supports availability zones. Second, you have to be on the basic tier or higher. And third, you guessed it, you need at least 2 replicas. That's it. You do those 3 things, and Azure automatically spreads your replicas across different physical buildings for you. And here is a fantastic pro tip, straight from the source. Don't just provision for a perfect sunny day. You should plan for failure by over-provisioning. So let's say you know you need 3 replicas to handle your normal peak traffic. Well, maybe you should run with 4. Why? Because that way, if a whole zone goes down and you suddenly lose a replica, your service doesn't even flinch. It can still handle all of its normal traffic without a performance hit. Phew, we have covered a lot of ground. We've talked about the blueprints, the light armor, the heavy armor. Let's bring it all together now into a final, super clear checklist. This is what you need to do point blank to make sure you are covered by that official service level agreement from Microsoft. The requirements are crystal clear, which is great. If your application is mostly just running queries, so it's a read-only workload, you need 2 replicas minimum to get that SLA. If you're also actively indexing new data, which is a read-write workload, you need to bump that up to at least 3 replicas. Anything less than that, whether it's a single replica on a paid tier or just the free tier, means you have no official uptime guarantee. None. And I've just got to say this one more time because it is so, so important. The free tier is an amazing tool. It's fantastic for learning, for development, for testing things out, but it is not for production. With only 1 replica and no SLA, putting a business-critical application on it is like, well, it's like building a house on sand. So we end right back where we started with this idea of shared responsibility. Azure gives you all the tools, all the armor you need to build a search service that is truly resilient. The question that's left, the one you have to ask yourself, is, are you actually using them? Take a minute after this. Go look at your configurations. Is your armor in place?